guys, welcome to JIK 224 E-Kuliah series. I am Dr. Sumia Sabab. So this is the second video covering chapter 2, which is chirality. Okay, so in this, upon completion of this topic, you should be able to recognize chiral structures, draw their mirror images, and identify features that may suggest chirality. So first, we look at what is non-superimposable mirror image. Okay, let's say if you have your hand, okay, you have your right hand, and then you place a mirror in the center, okay, and then you have you see that in the mirror will be your left hand, okay. So this is a mirror image to each other, but these two hands are non-superimposable. It means that when I put my hands together here, you can see that my right hand and my left hands, their fingers are not aligned to each other. Okay, so this is what we call non-superimposable mirror image. So they have a mirror image to each other, but they are not identical. Okay, when we overlap them, both of my right hand onto my left hand. So this is what we call non-superimposable mirror image. Okay, so here we have left hand and also right hand. When we try to overlap both of these hands, they are non-superimposable. Okay, left and right hands are mirror images, but they are not identical or superimposable. A molecule or object that is non-superimposable on mirror image is said to be chiral. Okay, let's look at another example. We place our car, okay, we're Malaysian, we drive like British, we drive on the right hand side, okay. When we place this car next to a mirror, we can see that it has a mirror image, okay. But when we try to overlap, these two cars cannot be overlapped because one is right-handed, a British car, and another one will be left-handed drivers, which is an American car. So you cannot overlap these two cars. What about a screw? Okay, we can see that one is pointing to the right and one is pointing to the left. So these two screw is a mirror image to each other, but they are non-superimposable. Why? Because one, we can tighten them by twisting the screw clockwise, while the other one, we have to twist it anti-clockwise to unscrew the screw. Okay, so there's a difference between these two. They are not identical. They have mirror image, but they are not identical. Okay, they have different purpose. What about a scissor? Okay, we can place the scissor in front of a mirror, and when we can see its mirror image. We might think that it's the same scissor, but it's actually not. Okay, when we place a right hand scissor in front of a mirror, we will see a left-handed scissor. So left-handed scissor is only for left-handed people, while a right-handed scissor is for right-handed people. So a chiral object has a mirror image that is different from the original object. So both of the mirror image of all these items are actually different from its initial object. So they are not identical, they are different objects. Okay, what if we have socks? Okay, here I have my daughter's socks. Okay, so this is when I put these socks in front of a mirror, I will see this mirror image. Okay, but when we try to superimposable the socks here, okay, we rotate the socks and we can see that it's actually an identical socks. Okay, it doesn't matter which foot you wear, the socks is still the same. Okay, it's different when you have right hand glove. So the glove is only fit to your right hand, while the left glove is only fitted to your left hand. So these socks, when we superimposable, is identical. Okay, this is what we call superimposable mirror image. Two socks from a pair are mirror images that are superimposable or identical. A molecule or object that is superimposable on its mirror image is said to be a chiral, not chiral. Okay? Okay, we now consider several molecules to determine whether or not they are chiral. To test chirality, you have to draw the molecule in 3 dimensions, draw its mirror image, try to align all bonds and atoms to superimpose a molecule and its mirror image. You can perform any rotation, but you cannot break a bones. Okay? So, let's say here I have a water molecules which is H2O. Okay, so I have here one molecule of H2O. Now, when I place in front of a mirror, I will see a mirror image of each other. Okay, but when I try to superimpose these two, I can see that they are identical. Okay, so when we align this atom, okay, we see that all the atoms and its bonds are identical. So water is achiral. Okay, let's say here I have a bromochloromethane. Okay, so chlorobromomethane, I have here the black ball here is the carbon, and then the blue here is bromine, and red here is chlorine, and I have 2 hydrogen atom here. Okay, so this is bromochloromethane. When I place in front of a mirror, okay, I have a mirror image, okay, of each other. Can you see? This is the mirror image of each other. Okay, we have the here is the bromine, chlorine, and hydrogen here are aligned to each other. When I try to rotate this molecule, okay, on my left, I can see that it's actually identical. Okay, it is actually identical. When I try to rotate anyway, okay, I can see that it's actually identical to the molecule on my right here. Okay, you see here that is actually identical. All the white are aligned, all the hydrogen atom are aligned, and then I have my chlorine here, blue, are aligned, and also my bromine in red are also aligned. So they are actually identical. So when you rotate the molecule to align bonds, the bonds and atom will be aligned. Okay, so bromochlorobromine is actually a chiral. Okay. Okay, what about a chiral molecule? Okay, so let me just align this. Okay, now we have bromochlorofluoromethane. Okay, so now we have 4 different groups. Okay, we have the bromine in red, chlorine in blue, and fluorine in yellow, and then also hydrogen in white. Okay, when I have its mirror image, okay, let's say the fluorine is pointing to each other. Okay, no matter how I rotate my left molecules, it is non-superimposable to this my right-handed molecules. Okay, I even when I try to align with the yellow, okay, yellow is fluorine, you can see we have the hydrogen aligned to each other, we have the fluorine aligned to each other, but the bromine and chlorine here are not aligned. Okay, they are not the same, even from the front and also from the back. They are not aligned to each other. Okay, so when we try to rotate this molecule, the atoms don't align. Okay, so they are not superimposable, and bromochlorofluoromethane is a chiral molecule. So molecule A and B are not superimposable. No matter how you rotate A and B, all the atoms never align. Okay, thus bromochlorofluoromethane is a chiral molecule, and A and B are different compounds. A and B are also stereoisomer, and specifically they are enantiomer. Enantiomer is a compound that is non-superimposable mirror image. Any molecule that is chiral must have an enantiomer. Okay, what is a chiral carbon? A chiral carbon is a carbon atom bonded to 4 different groups. Just now, like bromochlorofluoromethane, we have 4 different groups, which is bromine, chlorine, and hydrogen. Okay, so chiral carbon is also known as asymmetric carbon or chirality center. It is often designated by an asterisk. Okay, we can label the chiral carbon as star. Okay, so for example, here we have a carbon chiral with a star here that is attached to 4 different groups, and this is its mirror image. So now we have a pair of enantiomer. So let's try this example. Classify each of the following pairs as chiral or chiral. So remember, a chiral is when you have 4 different groups attached to a carbon. Okay, so now we have this carbon attached to only 3 different groups. Okay, we have chlorine, bromine, and then we have 2 methyl groups. So these are considered as one group. So we only have 3 different groups here. So this is achiral. Okay, because its mirror image can be superimposed. And then here we have 4 different groups, which is methyl groups, chlorine, hydrogen, and bromine. So its mirror image is non-superimposable. So this is a chiral. And then here, how do we differentiate between which carbon is the carbon chiral? So here this carbon, we have 2 hydrogen groups, which are not shown here. 2 hydrogen groups, 1 methyl group here, and then another groups here. So this is not the carbon chiral. So this carbon, we have, it is attached to ethyl groups, which is CH2, CH3, bromine, hydrogen, and fluorine. So this is its mirror image. So again, its mirror image is non-superimposable. So this is also a chiral molecule. So as a summary, all chiral molecules have non-superimposable mirror image. Every chiral molecule has an enantiomer. A chiral carbon is a carbon atom bonded to 4 different groups, which are we label it as asterisk or a star. It is also known as asymmetric carbon or chirality center. All achiral molecules are exactly the same as their mirror image. And achiral molecules do not have an enantiomer. Okay, so this is the reference. If you have any question, feel free to contact me at my email address, and thank you for listening.